Stop saying that we cannot quantize gravity. Gravity is absolutely quantizable at low energy. Namely, gravity will behave quantum mechanically. There's a wave function, there's a Hilbert space, there's a probability distribution, etc. for gravity. The problem arises when you try to naively extrapolate general relativity to high energy. What is the problem? When you try to compute some of the probability distribution for some certain scattering event involving gravity, the result you will get would exceed 100%. That means the theory is not predictive, or the result is nonsensical. We can get nothing out of it. So what happened? It implies that at high energy, new physics has to kick in to resolve that inconsistency. And we have a perfect analogy in particle physics. Consider the theory for strong interactions involving quarks and gluons. At low energy, quarks are going through a process called the quark condensate. It means that some of the degrees of freedom for quarks are frozen. The only degrees of freedom that you can excite at low energy are called the pions. Now, if you try to write down the self-interaction for pions, and you compute some of the probability distribution for pion scattering event, again, you'll find some nonsensical result, namely the probability exceed 100%. So does that mean we cannot quantize pion? Absolutely not. We know that we can quantize pions. It simply means at high energy, there are more degrees of freedom kicking in. And in this case, we know what those degrees of freedoms are. They're quarks and gluons. At high energy, these quarks and gluons defrost, and they'll enter the scattering event and resolve the inconsistency. So same would happen for gravity. At high energy, there are certain new physics kicking in. We simply do not know what they are. In fact, in string theory, it was argued that it's only possible to resolve this gravitational scattering inconsistency by adding infinite massive states. And it's computed using string theory, and it's kind of proven using some of the basic assumptions of quantum field theory. So if we detect high energy gravitational scattering event, we are able to verify string theory imminently.